Welcome to Virtual Petroleum Laboratory. I am Professor Uttam here. Today I will demonstrate TBP distillation. TBP stands for True Boiling Point Distillation, where usually crude oil distillation analysis is carried out for its quality when it is received by the refinery, which gives the more accurate distillation analysis as compared to ASTM distillation, as I have discussed in the earlier experiment. Today we will see there is a retort which is placed on a heater. The size of the sample can be taken from 1 liter to 5 liter. It varies with the types of accuracy of the experiment. So it may be 1 liter or 5 liter sample can be taken, and it's placed on a insulated system over a heater, and over this retort there is a cylindrical vessel or tubular vessel which is packed with some certain materials as prescribed in the ASTM D1160 standard, as you see from the ASTM book, where you will find that there is a outlet where the vaporized vapor which will come out from this to a pipe like your the previous one, which will be condensed by a condenser followed by another condenser to keep it cooled, so that the lowest temperature product can also be collected here. And there is another connection which is connected with the vacuum system. You will find that this crude oil is partly vaporized up to 50% around, nearly 300 degrees centigrade, and after that vacuum is applied to get the remaining vaporizable condensates from the residue. Now you will see there are reflux time. We can fix reflux time and distillate time. What is reflux? Is the vapor condensed which is returned back to the retort while the vapor is uprising, and the vapor and liquid condensates exchange its concentration, so that more volatile component will be concentrated and be collected, and distillate will be enriched with low volatile components and returned, and the vapor which will be enriched with the more volatile component will get a pass over this condenser and will be collected, and this collection will be made in terms of percentages for this cylindrical vessel, and the corresponding temperature is also measured at a point as prescribed by the ASTM standard. And this valve plug is a magnetic material which is lifted by the solenoid placed over here, so that time to time it will close it, and during that time condensate will return as reflux, and when it is opened the condensate will get a pass to be collected over the measuring cylinder. Now we can show you that the reflux time and distillate time is equivalent to the reflux ratio, where here it is as per standard is 5:1 ratio can be maintained. So here you can also change it and find a different type of analysis, but here according to standard it is maintained here, it's 5:1. So 5 minutes reflux means that this valve will be closed for 5 minutes, and the reflux will be whatever vapor goes up, condensed, and will return back to the retort, that is called reflux. And for distillate time, for 1 minute this will be lifted, and the vapor will this condensate will go to this collection vessel. So that is the system, but the time of the experiment is huge, maybe 8 hours or 16 hours depending upon the size of the sample. So here we in order to show the video in short time, we scale down the time first. We have selected this as actual 1 minute is here it is shown is 1 second. So if it is 5 seconds means actually it is 5 minutes. Now in the beginning, we take crude oil. Say this is usually used for crude oil. So we take crude oil, which is blackish in color, and pressure is 760 millimeter of mercury, which is atmospheric, maintained, and the corresponding distillation time we scale down it 1 minute equal to 1 second, and we will start this heater after a few minutes. It will be boiled up. Actually it will take at least 5 minutes time. Now you will see that it is boiling, and you can also observe this position of the valve, which is open and closed, which is also in terms of seconds. Actually it is 5 seconds and 1 seconds, but in practice it is 5 minutes and 1 minute. So this will be continued till around 50% of the residue is sample is distilled, and the remaining residue is then undergone distillation by applying vacuum. So now it is carried out at atmospheric pressure, and usually some time is allowed to cool down the residue and then start the vacuum. Otherwise, large quantity of condensates will come out. To avoid this, but here in this experiment you will see almost around 50% is distilled, and then application of vacuum is done, which is around 10 millimeter mercury or maybe lower, so that highest vacuum is applied to get the distillates. Now you see that drop by drop this is being collected, and the corresponding temperature is also being noted here on the top. So this is carried out till residual oil is coming, around 50% will be distilled, or the temperature will be around 300 degrees centigrade. Usually above 300 degrees centigrade, if you try heating, there will be cracking or the chemical change in the crude oil. So that's to be avoided. So we want to separate physically by distillation method, and we'll see how much pure products can be collected here. So you can see now this vacuum is applied already. Now it is much lower than 200 degrees centigrade. It is now under vacuum, it is being collected. So actually the experiment has to be conducted very carefully, and these standards must be maintained throughout the world, so that you will get the same TBP distillation and data for the crude oil coming from different sources. So for a particular crude oil there is certain distillation data. So depending upon that, distillation columns are designed, or the quality of the products which will be coming out from the column in the industrial scale will also be ascertained from this TBP distillation. And this method is very much applied and important, and there are many advantages, and improvements are also taking place for collecting individual temperature ranges or boiling fractions are in a rotating system of collection. That also gives product directly from this batch distillation method. I will see that this is the distillation data which has been according to the different pressure. For atmospheric pressure you can see up to 228, and then it is falls to 137 after cooling. So and in that case also we applied vacuum, and so on this vacuum this distillates are collected, and equivalent temperature at 760 millimeter is converted from various charts or some conversion factors, and this is uniformly at 760 millimeter. So we can see also in the graph this blue portion is up to 40% near about, which is slightly above 40, is around 45 or 50, and the rest is under pressure, under vacuum, and then its equivalent temperature is added here. So we will get a smooth curve of this according to this TBP distillation data. So this is very important for analyzing the quality or any crude petroleum products, especially crude oil. We can also carry out for lighter products, petroleum like petrol, kerosene, diesel, but usually it is not necessary because this system is much costlier than a steam system because of so many things like packings, which is considered to be almost equivalent to 20 equivalent plates in a industrial column, and the time of reflux and distillate also elongate more time for the experiment, and naturally the size of the retort is large. Heater is also well controlled temperature system, so naturally this process is very costly, but more accurate because of the presence of reflux. You must have studied about the effect of the reflux, which gives simultaneous mass transfer as well as heat transfer process for enriching the more volatile component in the collected vapors or distillates, and condensates will be enriched with the less volatile component. So this way we get more accurate result. I hope I could explain this process for the TBP distillation in practice, but there is no alternative for doing physically this TBP distillation. But in the laboratory, it has to be done more accurately and carefully, and it is a time-consuming experiment. Thank you very much for observing the video.